Welcome and thank you for joining us today. My name is Dave Daly. I'm the Product Marketing Director at GE Distribution Solutions, and I'll be your moderator for today's webinar. I'm very excited to be joined today's session by a representative from one of ADMS utility customers in Europe, Peter Hermans, CTO at Stedin. Welcome, Peter, and thanks for joining us. Also, we'll have one of my GE colleagues, Frederick Wicke, Senior DER Orchestration Product Manager, who will kick off today's discussion by taking us through the disruption we're seeing from DERs, and then talk us through some software solutions that can enable utilities to solve these challenges. Throughout this webinar, you'll have an opportunity to ask questions using the tool, and we'll plan to answer as many as we can before the end. And remember to ask those questions via the tool, and if we don't manage to cover all of them, we'll best endeavor to send emails as follow-ups. So for today's session, the key theme is about end-to-end DER orchestration. And this follows on from one of our earlier topics, our previous webinar, where we talked about the three pillars of a modern advanced distribution management solution. Starting off with distribution optimization, we're seeing how we're building on the traditional SCADA and DMS functions with more advanced applications that are both adaptive and optimized on their objective functions. Then on the second, we have outage response, where we're seeing we're moving beyond centralized OMS functions with the addition of mobility, damage assessment, and also more looking towards predictive analytics to help reduce and minimize number and the disruption from outages seen by utilities. And then finally, 3 is the DER orchestration, the focus of today's webinar. This is where we're seeing how we can turn the threat of DER into an opportunity. A DER-aware ADMS is not only fundamental to safe and secure operations in the future, it's an opportunity to unlock DER flexibility through better forecasting and orchestration. So at this point, I'd like to introduce Fred and have Fred kick off by talking us through the disruption we're seeing. Over to you, Fred.
Thanks, Dave. Hello, everyone. Very happy to be here and have this opportunity to exchange on distributed energy resources. And so indeed, we'll start with the disruption that these new technologies are causing to the grid. So, we all have nice stories about how fast are these technologies developing, and quite frankly, in all geographies. And so it started with wind, then was PV, and then storage, and now EVs. And so, we have here some samples which are quite illustrative of the level of democratization that these technologies have reached. And so today you can go out of an IKEA store with not just tables and shelves, but also some PV kits. Also here, some samples on storage, Tesla, Sonnen, and other parent companies who are offering very nice services to the end users thanks to residential or commercial or industrial level storage. And of course, EVs going very fast. This is a sample from the airport in Amsterdam, where the taxi licenses has been renewed, and the companies who won propose mostly, the cars that you see pictured here. So all of a sudden, in this particular airport, you've got EVs everywhere. So all of this is going very fast, and quite frankly, at a pace that utilities cannot really control. So what are the challenges that this cause to the grid? So distributed energy resources essentially challenge all the good old power system engineering paradigms that we use to build our grids upon. So if you see here on the left, obviously power flow goes down from transmission to distribution. Well, not anymore. Now you've got backfeed. Obviously, if you go to the center at the bottom, obviously voltage profile is such that voltage decreases alongside the feeder. Well, no longer, and you can now have voltage profile that actually increase. On the right-hand side, you see net load and native load. What that means is that, when you say the load is X on that particular feeder or substation, it doesn't mean a thing anymore. Are you talking about the native load, so the actual consumption, or are you talking about the net load, which is the native load minus what is already covered by distributed generation? You now need two terms. One is not enough. And all of this is further challenged with the intermittency, which you see at the top center here. That's a snapshot for a PV site during a cloudy day. And so what that means is that essentially the backfeed or voltage profile that you had a few seconds ago might be changed again. And so that's all very challenging. So all these new paradigms, they really incarnate both at the transmission and at the distribution level. Because any challenge happening at the distribution level will aggregate up to the transmission anyway, so it will materialize at the primary substation boundary. And the TSOs have their own challenges about, balancing reserve, lack of inertia, all the instabilities, and the lack of visibility that the traditional systems are providing to what's happening at the distribution level. Okay, so that's the big challenges that are really occurring for both the TSOs and the DSOs. So at this point, we would like to pause for this little polling question that will be very interesting to share in between all the audience here. We'd like to know what's the visibility that you have on the DERs that are today on your grid. So do you have actually no visibility? You know that there are some PVs around and some EVs, but you do not really have a grasp on where and what these are. That's the answer number one. And so number two would be, you know what's there, where it's connected. You have a first parameter like, okay, it's a PV of that size, but that's about it. Number three would be the same, but in addition to that, you have some awareness of what are the communication means that you can use to interact with this particular device. Okay. Number four would be the same, and you do not just have the visibility on what monitoring and control modes are available, but you started to implement some monitoring, so you do have a decent monitoring of most of these devices. And number five would be you not only have monitoring, but you also have the ability to control a big bunch of these DERs. Okay, so if you can please click the answer that best corresponds to your particular case, we could then wrap up with this polling result in the end. It would be very interesting. We'll let you 15 seconds to do that. So no visibility, mostly know what, where, and the capacity. In addition to that, number three, we know the communication means. Number four, we can monitor. Number five, we can also control. Okay? Okay, so let's move forward then. So facing this disruption, how should one address this disruption when running a transmission or distribution grid? The slide you see here kind of pictures the traditional landscape of all the systems that you need to run a distribution or transmission grid. So you've got your GIS, Geographic Information System, you've got your planning system, you've got the DMS, or ADMS, you've got the EMS at the transmission level, you've got the market management system run by the market operator, and you've got the market player, Gencos, retailer, who have their own system. Okay. So what does it take to manage DERs? Does it take to add one DERMS system somewhere here? And by the way, there's a blank right here in the middle. Maybe this would be sufficient. Well, it's a bit more complex than that, we think. What it takes is adding all the blue characters that you see here, the blue fonts. So you need to add some stuff deep within your GIS so that it manages DR. You need to add some stuff deep within your planning. You need to have some stuff deep within the DMS, EMS markets everywhere. So basically, you need to evolve all these systems with DR capabilities so that they can manage end-to-end these new devices. And so you've got themes that are going across, right? So how do you interconnect DRs? This is throughout. How do you model DRs? This is throughout. How do you forecast these devices' behavior? This is throughout. How do you analyze? How do you optimize? How do you control? How do you trade the flexibility to help solve the issues that these guys were causing? All of this needs to be carried throughout the board, through all these systems. And that's what we're building at GE. So today we'll focus on two aspects. One will be the modeling, and I'll talk a few slides on this. And then we'll go to the forecasting, and that will be thanks to Peter Hermans from Stedin, who will talk to us about a very interesting project. So starting with the modeling first. Modeling is across the board. You want to start with your GIS, right? Your GIS today is the repository for all your assets, the breakers, the lines, transformers, etc. Well, you want it to be also the repository maybe for all these new devices. And what will happen is that you will have a whole lot more parameters. It's not just static technical parameters, but it will be contractual parameters. You know, what's the interconnection contract for that DER? What is the aggregator contract that this DER has if I want to control it? And a whole range of very dynamic parameters, starting with the forecasting, the status, the dispatch capabilities that are left according to the contract, etc., etc. So you need to model the DERs right from the GIS, and it takes a lot more parameters than traditional assets. Then come the planning and hosting capacity analysis piece. Today, utilities have this traditional process to say, hey, here's a candidate load to connect on the grid. Can I accept it? Yes, no. Well, until now, these loads were just loads. But now, any load can have a PV on its rooftop or an EV charging station in its basement, right? So you need to enhance all your connection analysis processes to be able to take into account the specific behavior of these DERs. And of course, when you project further, you say, hey, I want to have a snapshot view of what's my hosting capacity analysis left. So on any particular feeder or substation, how many more DERs can I connect before, I just break the capacity and all the constraints? And so that's the type of analysis that need to be carried out. That takes simulating DER trends of various types and running all types of network studies so that you can see where the constraints will come, and ultimately also being able to take into account the DER control modes that you will have to say, okay, maybe DERs are not just a threat, as Dave was saying, but also an opportunity to actually, remove some traditional copper investment. Modeling needs to happen also in the ADMS for sure. So your regular ADMS needs to be able to model any type of DER, be it generation, storage, controllable load, whatever, and all the particular processes that it runs today, the power flow, the fault location, isolation, service restoration, all of these, they need to be able to account and to run in presence of backfeeds, in presence of new types of voltage profiles, in presence of hidden load and everything. So that's the modeling and awareness within the ADMS. And that modeling, of course, needs to be consistent with what you had, captured within your GIS. So there needs to be the right process to move the data from one system to the next and all the consistency workflow around that. Then through the EMS, obviously, the DERs need to be modeled too, right? So at the transmission level, a big PV or a big wind farm or a big storage unit is modeled. But also you want at the boundary to be able to model within your EMS at transmission level what's happening downstairs, what's happening in terms of the feeder, not just feeder load, but feeder equivalent generation and feeder equivalent storage. And this takes, some modeling into the systems, but also some tight discussions between the TSOs and the DSOs. And that's, I guess, a good segue to the next part. Back to you, Dave.
Thanks, Fred. Some great insights there on the needs and benefits of taking that holistic view, as well as a good introduction into the different aspects around the DER modeling. So the next topic we wanted to cover was really getting into about DER forecasting. So at this point, I'd like to invite Peter to talk in particular about Steden's recent project on predictive load forecasting. Peter?
Yeah. Good morning or good afternoon, depending where you're listening in. My name is Peter Hermes, Chief Technology Officer of Steden. The next few minutes, I would like to talk a little bit about what we did together with GE on forecasting. First, a little bit about Steden. Steden is a Dutch DSO, distribution system operator. We serve 2.2 million customers in the southwest of the country. You see that in the yellow area here in the picture. And we operate in electricity infrastructure and a gas infrastructure. And as I see a lot of people listening in from the United States, the market model in Europe is about unbundling. So you have distribution system operators and transmission system operators responsible for running the grid and maintaining the balance. and supply to customers, and trade and generation is a function which is to the commercial market. So we operate the grid in Rotterdam, and actually today we operate the distribution grid actually from what we normally call a copper plate principle. So we have capacity, and no matter what everybody is doing and putting energy on the grid or getting load off the grid, it would always fit. And actually that is a situation which with the future energy transition and with a lot of decentralized energy resources and dynamic pricing will not be valid for the future anymore. So that was what we saw coming, and actually we combined that with an actual situation, because today the distribution system operators in the Netherlands, they have the legal obligation to every day, 3 times a day, to produce forecasts to the transmission system operator about the transport prognosis on the interface between the distribution grid and the transport grid. And based on that, the transmission system operator, which has also system operations responsibility, calculates whether the energy program fits into the capacity of the grid. Well, we had an outdated homegrown application there a few years ago, which we planned to phase out. So at that time we said, well, we have to renew that application, and at the same time, let's make it a little bit more future-proof, and that we do the forecasting not only as a legal obligation to the transmission system operator, but also as a function for ourselves, and really start to learn what is happening in our own grid. Because I said to the manager of the network operations center, you have a fine SCADA system, so you can really monitor real time what's happening, but you have no guarantee that within 10 minutes you will hit the wall in problems, because you don't know what is coming. So in the era of where we are going to, predictive, we say is very, very much important. Well, on that topic, we engaged with GE, because we had also the GIS of GE and also the distribution management from GE. So well, this should fit in your portfolio, and then in a co-creation, we started to work on this. And that resulted, I think, in a very nice application. And I show you 2 screenshots here. Well, this is a screenshot of the Steden area, and the system is actually fully operational since a few months. And our territory covers, as I said, 45 interfaces to the transmission system operators, 200 primary substations, and more than 22,000 secondary substations. And on a daily basis, multiple times per day, we calculate now the forecast on these 45 interfaces to the TSO, and we do that based on data which we get from the historical database from the distribution management system. But we produce also the forecast based on data which is imported from the balance responsible parties, which are outside in the market. We get all that data in, we calculate the forecast, we do validation of the input data, we do an estimation, and then we do an extrapolation, and based on that we produce the forecast. And in this phase it's the forecast towards the TSO, and in the next phase it will be also the forecast for what is happening on the medium voltage level, and maybe even in the future on the lower voltage level, because there's a lot of dynamics in the grid. As I said, in Netherlands we will phase out gas, so that means that we will go further in electrification. We see a lot of uptake on electrical vehicle charging, and we see also dynamic pricing coming. Today there's fixed prices for customers, but in the future there will be dynamic pricing, so there will be actually a lot of dynamics in the grid. This is a slide where you actually can see the screen of how the operators work with it. Here you see a trend over a day with a forecast, and actually we do more as what you see here. We do not only create the forecast, but the day after we also receive the data from the metering companies, and we can also see what actually took place that day. And based on the difference between what took place and what was forecasted also by market parties, we make a judgment, and we have some discussions with market parties and also with the regulator to improve the forecasts from the market parties here. Because if those forecasts are not correct for market parties, then it's for the distribution system operator very difficult to predict when and where we might hit a problem. This is the setup on how the forecasting application is located. You see clearly it's interconnected to the GIS, getting the network model in. It is connected to the distribution management system, getting also the historical data in, and we are now working on for 2019 also that the model in the forecasting application will be dynamically synchronized with the actions taken in the distribution management system. You see the receiving data from the BRPs, you see the receiving data from the metering companies. You see in the future, and that is also in the roadmap, that we start to take in weather data, because also that is an important factor when we have to forecast what is going on the grid based on photovoltaic and wind farms. And based on that, we produce the forecast to the TSOs and for ourselves. Now you see in this picture also an arrow to the right to the marketing and trade platforms. Because if we now today say we have a problem because the forecast is exceeding the capacity, then we have to do some curtailment activities, etc. And for the future, flexibility is a hot topic in Europe. We will go to the market and we will request bids from the market to reduce load, for which we will have to pay for. And then we will make sure that the capacity of the load is well within the capacity of the grid. Actually, on going to the market together with other Dutch DSOs and also with the TSOs, we work together. And actually, yesterday in a conference in Brussels, we announced the launch of a flexibility platform there. In which we really will do this, and this will start in the beginning of next year. And that is the last slide I show you here. So you see how the whole setup works. Doing the forecast in a forecast application which we developed with GE, and based on the triggers which comes out there, we produce that data to the platform which we do with the TSOs and also DSOs, and we interact with the market. And on the moment we have bids activated in the market to reduce certain loads, then the confirmation is going back to the forecast application, so to make sure that we covered a possible congestion point. So what you see here is that we try to really scope and to position the application in a whole new chain. Because in Europe, flexibility is really high on the agenda, because if we feel that if we don't work on flexibility, then we will not end up with an affordable energy system. And also the European Commission in their future energy package regulation is heavily pushing towards DSO starting to use flexibility. Well, I recognize it's only 10 minutes, I could talk for hours, but that's not the length of this webinar. So I give back to David, and well, if there are any questions within this time frame, well, I will see them. Thank you.
Thanks, Peter. Excellent presentation, and congrats to you and the team at Stedin for a really innovative project there. So before we get to the Q&A, I'd just like to take a minute to recap the results of the poll question that Fred asked earlier. As you can see here, it looks like we have a clear winner with the number 2, with 46% of the votes coming in that really only know what and where capacity. So Fred, is that what you were expecting from this poll?
Thanks, Dave, and thanks everyone for answering the poll. Yeah, that's very, very interesting. I would have said that indeed it was close to that. Now it really varies around geographies and maturity of particular DSOs and TSOs in terms of what's the DR penetration and how bad this translates into the grid and how much they need to do to cope with it. So yeah, that's very, very, very interesting. I guess no matter the level of DR penetration today, one of the key feedbacks we get from front runners is really that it's a lot of homework to go through this transformation we were mentioning throughout all the systems, and running on all the new paradigms of the new modeling, the new forecasting, and all the market stuff that also Peter touched upon. Trading flexibility to manage the grid instead of just pressing the buttons for the particular breakers or transformer that are your own. Now you need to use a leverage that is not your own anymore. So all this is a whole set of new challenges and new paradigms that need to be started, with quite a lot of homework earlier on. So it's very interesting to get this view, and and thanks again for everyone for answering to that. Great,
thanks, Fred. So I think we've got a couple minutes left, so we should be able to get a few questions in here. So just a reminder, if you haven't already and you want to ask a question, you can do it through the tool. So Peter, maybe I'll start with you. I've got one here. Why is this project so important to you? Can't the grid operate in real time?
Yeah, well, what I said already, we have to cope with future dynamics of the grid. And the current strategy of the grid is, well, you just invest in copper and transformers. Well, if we would do that in the future, that would lead to a very unaffordable grid. Actually, we don't have the money, and also we don't have the people to build all this new infrastructure in time. So therefore, for us, it is important to interact with the market, and before we interact with the market, we really want to predict what is coming. So it's really a fundamental, cornerstone or building block, as you could say, for how in the future we would run the grid.
Great, thanks for that. Fred, one for you. How do you interconnect to DERs, and do you model microgrids?
Okay, so first, how do we interconnect with DERs? So there are two main ways, right? One is SCADA, maybe for big DERs, typically a big network size type of battery. The utility may want to interconnect it using SCADA, and especially because the asset is worth the investment or proper RTU and all of this, and also there's all the latency control that is very important. Maybe if this particular asset needs to provide some demanding system services also at the transmission level, etc. So big DRs, SCADA might be a fit. Now, what we see for the bulk of the DRs is the emergence of a particular standard that is very useful and very promising, which is IEEE 2030.5. This particular standard was born in California, and it's really useful to enable communication to single DRs or to groups of DRs, and soon also directly to aggregators. And so that's really the standard that we see emerging. It's here for long, for sure, and so that's part of what we are providing within the theme of the DR interconnection. There was a second part to the question. The microgrids. So microgrid. Yeah, thank you. So microgrid can be seen two ways. In a number of circumstances, you can see it as a collection of particular DERs, right, that you want to monitor, that you want to understand what's happening within the perimeter of the microgrid in a typical grid connected situation. Now, what you also want to do is to consider a microgrid as a big DR, right? You will certainly have a particular microgrid management system that would run the microgrid for cases when it needs to island, typically. And so part of what we're building within our orchestration solution is the microgrid management system, but also all the interaction between the typical ADMS and EMS and the microgrid, so that this particular perimeter can actually provide some services to the higher grid level. I hope that answers.
Great. Yep, thanks, Fred. Well, I think we've got a few more coming in, but unfortunately we are up for time, so we will get back to each of those that have asked questions via email. So I'd just like to close by first A big thanks to Peter and Fred for your time today and some great presentations and discussion. And also just like to thank all of you that have taken time out of your busy schedules to join the session. And we hope to talk to you all again soon. Bye for now.